Welcome to How It Works. This week, we will be talking about the near-infrared spectroscopy, or NIRS, and how it is used to measure oxygen activity in muscle. NIRS monitors muscle oxygen, in other words, the supply and demand of oxygen in muscles. This information can be used to figure out the muscle metabolism in healthy or diseased patients and in athletes. This information is important for athletes who want to measure training intensity and duration. Coaches who want to adjust their athletes' training technique and who want to avoid injury may also use this technology. In addition, rehab professionals may use NIRS to assess effectiveness of therapy and observe physical fitness in patients. Muscle oxygen is the amount of oxygen the muscle uses and indicates how much energy is powering the muscle. Measuring the oxygen used will indicate the intensity exerted by the muscle. The more oxygen present, the more the muscles use aerobic metabolism. The less oxygen present, the more the muscles use anaerobic metabolism. NIRS measures muscle capillary oxygen saturation. Near-infrared spectroscopy is based on the relative ease with which near-infrared light found on the 700 to 1000 nanometer region of the electromagnetic spectrum passes through biological tissues, including bone, skin, and muscle. One optode illuminates the tissue with pulse light, and another measures the amount of light recovered. The amount of light recovered after irradiating the muscle depends on the degree of scattering in the tissue and the amount of absorption by the chromophores in the tissue. Hemoglobin, myoglobin, and cytochrome C oxidase are the only three molecules known to affect NIR light absorption during muscle changes. During exercise, cells need more oxygen. Therefore, the hemoglobin in the blood will be less saturated as it tries to get the oxygen to the body. The metal oxidized in the hemoglobin will determine the amount of oxygen stored in muscle. The less oxidized metal, the less oxygen stored.
First of all, we need to know how the absorption of light works. When light is absorbed, its energy is dissipated in the thermal energy throughout the absorber, and the absorption occurs at specific wavelengths. The primary light absorbing compounds in tissue within the near-infrared range are called chromophores. And there are three types of chromophores interested in muscle oxygen, as mentioned before: oxyhemoglobin, deoxyhemoglobin, and cytochrome C oxidase. The concentration of these three chromophores varies with time and oxygenation status. Each chromophore has a unique absorption spectrum. However, cytochrome C oxidase does not have a significant effect on the measurement because the effect on the attenuation signal is 10 times smaller than hemoglobin. So oxyhemoglobin and deoxyhemoglobin are the two most interested chromophores. NIRS instruments utilize light in the 700 to 1000 nanometer wavelength range to trans-illuminate cerebral and muscular tissues. This range follows from the increased absorption bands of water above 1000 nanometer and the increased scattering and more intense absorption bands of hemoglobin below 700 nanometer. In the 700 to 1000 nanometer range, hemoglobin and oxyhemoglobin have unique absorption spectra, which allows emitted light to propagate through tissues for several centimeters. The attenuation of the emitted light can be related to the change in chromophores concentrations using the modified Beer-Lambert law shown here. So A is the absorption of light expressed as optical density. Epsilon is the extinction coefficient of the chromophore. And C is the chromophore concentration. L is the distance between the point of light entry and exit. B is the path length resulting from scatter in the tissue, and G is the lumped parameter related to tissue and optoid geometry.
Other ways of measuring muscle oxygen include transcutaneous PO2. However, it only measures oxygen dissolved in the skin. Many athletes will measure their VO2 max, which is the maximum amount of oxygen someone can use for energy during an activity. This measures the aerobic capacity, not the intensity of the workout, however. There are several limitations to the NIRS technology. It is possible to have interference from non-targeted chromophores. The skin which the optodes are placed on contains melanin. Melanin has an optical effect on skin reflectance and at certain wavelengths has a specific extinction coefficient which could affect the readings. There is also an unknown amount of chromophores lost due to scattering. There are methods to approximate the amount of light scattered, however, there is still uncertainty. NIRS is unable to differentiate between venous, arterial, or capillary blood. It may also account for blood flow in the skin, not just the muscle, affecting the results. Despite these limitations, NIRS has been found to be accurate and measures can be repeated among individuals. It is a great way to measure the intensity of the user's exercise, and the information gathered from this technology can help athletes to modify their training and techniques.